Hi everyone, welcome back to the Generative AI world. So, in this module, we have already introduced embeddings, vector database, semantic search, and we know what they are and how they work. Let's now work on a hands-on project so that you can understand how embeddings, vector database or semantic search are working in background and how we can use them in our code. So let's go to the notebook. So this is my notebook. First of all, here I'm using one model for embedding and the another one is the vector database. Here I am using ChromaDB as my vector database and I am using Google Gemini model for embeddings. So first you have to install both libraries in your Python environment. For that you can run that code you are seeing on your screen. As I already installed those libraries in my environment, so it did not take time. If you install it first time, it will take some time. Next is the import statement. Once I imported, then you also needed an Google API key which you can generate from Google's website. So I already generated my key and I will run this cell. It will ask me for the key. As I previously provided my key, it is saved on environment variable. That's why it not asked for any key. If you run in first time, it will ask for a key. At that time, you have to pass the Google API key, which you are generated from Google's website. Next, here I am loading the Google's embedding model in the embeddings variable and the model name is embeddings001. This is a function of ChromaDB which uses the embedding models to first embed the documents and then store it in a collection. Here we give the collection name as I have given example and the directory will be where the collection is saved, where the DB file will be created. So my DB file will be created beside this Python notebook and the name will be chroma langchain db plus test. So I will run it. Now, here are few sentences. How can I change my password? Resetting login credentials, modifying account access info, and how are you? Here, these three are similar in a way, and this is not similar to those three. So according to the logic, when our embeddings are created and stored in vector database, those three will be stored closely to each other and this will be stored at a distance from those three. So let me run this cell. As you can see, these are the embeddings generated by our model, Google's embedding models, and these are stored in the vector database. Now let's run a similarity search. Here I am searching change the password and I am searching for top 3 matches. If you want, you can increase it according to your need. So let's run this cell and let's print what we got from VectorDB. So as you can see, I got those 3 sentences which are related to change the password. As you can see, there is only one sentence which matches exact keyword, but apart from this sentence, those two did not match any word with the sentence which we are looking for. So you can see, using embeddings, we search for the meaning, not exactly for the words, but for the meaning, what the words are meant to be. In our upcoming module, we're going to implement all those embeddings, vector database and similarity search to build a RAG, and there we will give you some assignments to build some RAG models which you can use in your daily life. Thank you.